All right, this is from the 4.5 assignment. I'll be checking this today. And number 29 says solve for x in the given interval. You should be able to find these numbers without a calculator using reference triangles in the proper quadrant. So number 29 says that the secant of x is equal to 2. And additionally, they want an x value that is between 0 and pi over 2. So we have to use the clues that we're given to know which quadrant to draw our reference triangle in. I'd say this is a pretty clear clue right here. From 0 to pi over 2, that's fully in quadrant 1. So my triangle is going to end up in quadrant 1. And here's my reference angle. And in this case, the reference angle actually is x. Quadrant 1 is the only quadrant where the reference angle is the same as the angle that we're solving for. But this one is x, bless you. And if the secant of x is 2 over 1, remind me what is secant again? Inverse of, or the reciprocal of cosine. Cosine's adjacent over hypotenuse, so secant would be hypotenuse over adjacent. Hypotenuse over adjacent, agreed? So the hypotenuse is 2 and the adjacent side is 1. And then we think to ourselves, oh my gosh, that's a 30, 60, 90 triangle, isn't it? If it's got a 2 and a 1, it must be root 3 over here. So x is definitely not the 90. The 90 is right here. Which one's x? Is it the 30 or the 60? It's the 60. Remember, the bigger side's always across from the bigger angle. 1 is the smallest, so this angle would be the smallest. That's our 30. Here's our 60. So x is 60. What others can we talk about? Yes. Oh, hang on a second, though. I bet if I looked up the answer in the back of the book, they would not give me 60 because they told me x needs to be between 0 and pi over 2. I'm guessing they want an answer in radians, so we probably better change this in radians, pi over 3. Okay, back to number 9, you said? Number 9. We are graphing here. Y equals 2 cotangent 2x. Or is it negative? No, positive 2 cotangent of 2x. It says describe the graph of the function in terms of the basic trigonometric function. Locate the vertical asymptotes and graph 2 periods of the function. All right. So what do we know? Well, if I'm gonna do my my transformations now. So my parent function would be just cotangent of x. And then we're going to do a couple transformations on it. I'm going to do my vertical stretch first. So this would be a vertical stretch by 2. Are we comfortable with that? We're multiplying on the outside. We multiply on the outside. We're either stretching or shrinking depending on whether that number is bigger or smaller than 1. And then we'll take care of that 2 that's on the inside. So here my transformation is to, now hang on, this is a horizontal. We're multiplying by a 2. A horizontal shrink by a half, right? So when we see the 2 multiplying on the inside, we're actually thinking about its reciprocal. We're thinking about a half. So if a half would be a shrink, yes. So horizontal shrink by 1/2. It might also be useful to us to talk about the period of these things as we go. What is the period for just regular old cotangent? We learned on Monday that tangent and cotangent do not have a period of 2 pi. They have a period of pi. When I do a vertical stretch, does that change the period at all? Vertical stretch? Nope. So period would stay pi here. But when we do our horizontal shrink by a half, that's going to change the period, isn't it? It's going to be half as long. What's my period going to be? Pi over 2. All right, so I know I need to do 2 periods. Does it say to graph? Yes, it says to graph 2 periods of the function. And let's see here. Okay, so I'm going to start my axis here. Let's see. 2, 3, 4. I'm going to make that 1 period. 1, 2, 3, 4. So 1 period will get me to pi over 2. 2 periods would be 2 pi over 2, or just pi. I need to locate my vertical asymptotes and my x-intercepts. So what I'm going to do right now is I'm going to think about, we're graphing a cotangent function, but I'm going to think about graphing, cotangent was sine over cosine, cosine over sine. Cotangent is that sine over cosine, or is it cosine over sine? Cosine over sine. Tangent is sine over cosine, cotangent is cosine over sine. So I need to think about where's cosine equal to 0? That's where my cotangent is going to be equal to 0. Those will be my x-intercepts. Wherever sine's equal to 0, that's where cotangent is going to have a vertical asymptote. We didn't do it quite this way on Monday, but I'm going to actually sketch my cosine and my sine just really quickly. Here's a period of cosine. Ooh, hang on a second though. I'm second guessing myself here. No, that is not a period of cosine. Sorry. What'd I mess up there? I fit my cosine into 1 period of tangent, but do tangent and cosine have the same period? No, so my cosine period is actually going to be 2 periods of this tangent. So let me redraw my cosine. There's my cosine, and that's going to help me locate my zeros or my vertical asymptotes. My zeros. So my zeros of cosine are going to be my zeros of my cotangent. So I know I'm going to have x-intercepts there and there. And I'll go ahead and sketch my sine also. So there's my cosine. Here's my sine. And my zeros of my sine are going to help me locate my vertical asymptote. So I'm going to have a vertical asymptote here at the y-axis. And here at pi over 2. And here at pi. All right, so I'm reading the instructions again. Locate the vertical asymptotes. Okay, so we've got our vertical asymptotes at pi over 2 and at pi and 0. I should be writing x equals. That's for these 2 periods. If I wanted to write my vertical asymptotes in a more general form, like write something that would give me all of my vertical asymptotes, where's the first one? Say the first one is at 0, plus how far in between each one of them? Pi over 2, n, where n is an integer. And I could leave that 0 plus out. All I have left to do is graph this. This is cotangent. So I need some points now. When we graphed before, we graphed some points that were kind of in between our intercepts and asymptotes, and they were always at a height of 1. But these aren't going to be a height of 1 this time, are they? 1. These are going to be. What's the height going to be for those points now? It's going to be 2 because we've been stretched vertically by 2. So, and I just have memorized that you've got one up here, and then the next one is going to be down low here. So we'll have one here and one down low. So there's my graph. All right, so I reason my way through. I'm not a big memorizer. I've told you guys that several times. It's not something that comes easy to me. My students who are memorizers might memorize that a cotangent graph has one period. It's got vertical asymptotes at the beginning and the end. And it goes through, oops, sorry. So one period of a cosine graph, they might memorize that it looks like this. It's got vertical asymptotes at the beginning and end. I said cosine, I meant cotangent. And that one period of a tangent graph is going to have intercepts at the beginning and the end and an asymptote in the middle. And it's going to look like, sorry, not there. It's going to have the points kind of at the same spot. And it's going to look like this instead. So I'm not a big memorizer. I'd rather just, I know my cosine and my sine really well. I'd rather just sketch my cosine and sine and use that to help me figure out how the thing's going to look like. Questions? These points here? Yeah, so this is going to be at something, comma 1. How do I get them? Like, so how can I reason my way to get them? So for my parent function, if it's just tangent x, tangent sine over cosine, right? So if I'm looking for a point that has a y-coordinate of 1, then I'm looking where sine and cosine have to be the same value. Something divided by itself is what's going to give me that value of 1. So I think to myself, where on the unit circle are my sine and cosine going to have the same value? They would right here. Sine and cosine are both the same there. There's our 45-degree angle. So, yeah. Remember, this has a period of pi or 180 degrees, right? So this would be a quarter of that. That's our 45-degree angle. And then another 90 off of that, this point right here is going to have the same x and y coordinates, but one's going to be positive, one's going to be negative. So that's where the negative one comes from. Or you can memorize it. I'm not a memorizer, though. I'd rather know, like, 2 key concepts and use that to come up with 50 other things than try and memorize 50 separate things, because I'll mix them up. All right, what else? What other questions y'all have? I'm hopeful that when you did this work, you used your calculator to check and see if your graph looked correct. Let me go ahead and model that. We're graphing trig function, so I want to be in radian mode. I'll type in my function here. It's cotangent, 2 cotangent 2x. I don't have a cotangent button, but I can do 2 times 1 over tangent 2x. So that would, 1 over tangent 2x is the same as cotangent 2x. And I'm going to set up my window. I'm going to make my x's go from 0 to, what was that, pi over 4? 0 to pi over 4 by, oh, it's pi. You're right. Thank you. Good catch. That's just pi. And each of these kind of tick marks here, I don't know, maybe I'll do a tick mark at pi over 4. Yes, I'll do a tick marks at pi over 4. And my y is going from, we want to be able to see like the negative 2 here, so maybe I'll make it go like negative 4 to 4 by 1. Let's see if that matches. Yeah, it's looking pretty good. If I wanted to be even more confident, I might graph y equals 2 and y equals negative 2 and see if I'm hitting these points at the right place. Looking good. All right, what else? What other questions y'all have? Yes. 33? Yes, thank you. 33, we're solving again. This one's a cosecant. You guys, have I told you my super lame cosecant joke? It's actually not mine, and I don't know who came up with it. So I'm guessing it was a really good friend of Mr. Ganger. It's about Mr. Ganger. This question may or may not be on the final exam in here. It has been in the past. The last question on the test is, can Mr. Ganger dunk a basketball? And the options are, it's multiple choice. The options are the 6 trig functions. What's the right answer? Can Mr. Ganger dunk a basketball? Which of the 6 trig functions is the correct answer? Now. Today. Answer is cosecant. Yeah, I didn't make it. I'm guessing it was probably Mr. Work or Mr. Skaggs that made that. He could. There was a time. Maybe he can. I don't know. We should ask him. Yeah, when you see Mr. Ganger, ask him if he can dunk a basketball. Tell him that he's still on the pre-calculus final exam. All right. Cosecant. We need more information than this. They also told, what is this all about? 2 pi to 5 pi over 2? What? 2 pi to 5 pi over 2. Okay. We're going to have to think a little bit about this. So 2 pi is here. And 5 pi over 2, so that's 4 pi over 2. Oh, yeah, 5 pi over 2 is right there. Okay, so it's in the first quadrant. It's in the first quadrant. So let's build ourselves a reference triangle. Our reference angle is going to be x. Cosecant is, this is going to be an interesting one. Cosecant is hypotenuse over, I'm thinking about sine, hypotenuse over opposite. We want our hypotenuse and our opposite to be 1, which is not possible if this is a triangle. It's actually not going to be a triangle. If I think about this leg starting off kind of small and growing towards 1, what's that angle going to, as it grows, isn't that going to kind of push our hypotenuse up, 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 up? And then eventually, when the two match each other, what's our angle going to end up being? It's going to be 90 degrees, but we got to give an answer in here. So yeah, 5 pi over 2 would be at the same spot. So yeah, that's an interesting one. X is 5 pi over 2. Here's another way to think about this. Okay, if you didn't like that explanation, if cosecant x is 1, then what is the sine of x? I just did a reciprocal from here to here, so it would also be 1, agreed? Okay, and I'm thinking, ooh, if sine is 1, that means on my unit circle, my y coordinate would have to be 1. Where does that happen on my unit circle? The y coordinate is 1 only at that point, right? So we must be talking about that, so that would mean my angle is 90 degrees, but we got to give a version of 90 degrees that's in radians, so pi over 2, but we want a version that's somewhere between these two things. 5 pi over 2 would be at that location. So here's another way to think of it. All right, guys, well, let's get started on our assignment, and our notes, and if we've got more questions about the assignment, we should have some time. We'll be checking that later on. Yep. Yeah, I have 2 assignments to check today. The word problem, that handout with the curve fitting, and then the one that we were just talking about.